The Caspian Sea. A vital resource under stress. A choice still exists. Not for the distant future. Not for the next century. But now. The Caspian Sea, the world's largest inland body of water, is shrinking. Not suddenly. Not by accident. But by consequence. What happens next depends on the decisions made today. By governments, industries, and societies that depend on this sea for food, energy, and trade. Satellites already show the outcome of inaction. The giant inland sea. Measured by surface area, the Caspian Sea is the largest inland water body on Earth, spanning about 371,000 square kilometers. Measured by economic value, social dependence, and biodiversity, it is priceless. It touches 5 countries, Russia, Kazakhstan, Azerbaijan, Turkmenistan, and Iran, and supports millions of people across Eurasia. And today, it is shrinking. To understand why the Caspian Sea is retreating, we must first understand how it works. And why this sea is unlike any other on Earth. Geography and why it matters. The Caspian Sea sits in a closed basin. It has no outlet to the world's oceans. Its water balance depends entirely on what flows in, mainly rivers, and what is lost through evaporation. Nearly 80% of all freshwater entering the Caspian Sea comes from one river, the Volga. This fragile balance makes the Caspian uniquely vulnerable. When inflow decreases or evaporation rises, the sea has nowhere to recover from. Life and biodiversity. The Caspian Sea supports a commercially vital fishery and provides livelihoods for millions of people. Its waters are home to nearly 90% of the planet's remaining sturgeon, making it the world's last stronghold for this ancient species. In the northern Caspian, shallow waters support rich ecosystems of mollusks, crustaceans, fish, and migratory birds. This is also the only part of the Caspian where winter ice reliably forms, ice that Caspian seals depend on to give birth to their pups. Every species here relies on one thing: a stable water level. That stability is now disappearing. NASA sees the change from space. On September 19, 2022, NASA's Aqua satellite, using the MODIS instrument, captured a detailed natural color image of the northern Caspian Sea. The Volga River delta appears dark green as it enters the sea. Sediment stirred from the shallow lakebed swirl in light green and tan. But along the shoreline, something else stands out. Wide light gray bands and white mineral patches mark areas where water once existed. These are salts and minerals, left behind after evaporation. For comparison, NASA examined an image from September 20, 2006, taken by the Terra satellite. At that time, the northern shoreline showed no salt-covered halo. Water-filled winding channels and shallow bays. 12 years later, those same areas had hardened into thick mineral crusts. The change is dramatic and measurable. Measured decline. Radar altimetry data compiled by NASA's Global Water Monitor shows that the Caspian Sea's water level has been falling continuously since the mid-1990s. Between 2006 and 2024, the water level dropped by about 2 meters. Today, the Caspian Sea stands at 29 meters below global sea level, the lowest level ever recorded. Scientists warn that this decline is not temporary. Climate change, the primary driver. Unlike oceans, which rise as the climate warms, closed inland seas like the Caspian respond differently. Between 1979 and 2015, average air temperature over the Caspian Sea rose by about 1 degree Celsius. That increase sharply intensified evaporation. Changing wind patterns further accelerated water loss. According to the United Nations Environment Programme, evaporation driven by warming temperatures is now the dominant force behind the Caspian's decline. The Volga River under pressure. The Volga River stretches 3,530 kilometers, making it the longest river in Europe and the economic backbone of Russia. Along its course, Russia has built a chain of 8 massive dams and reservoirs. These dams generate hydroelectric power, support agriculture, enable industrial cooling, and keep inland shipping routes open. But they also store water, increase evaporation from reservoirs, and regulate seasonal flow. At the same time, climate change is reducing snowfall and altering ice melt patterns in the Volga basin. Less freshwater reaches the Caspian Sea year after year. A sea rich in oil and gas. The Caspian Sea is also one of the world's most energy-rich inland basins. Beneath its waters lie an estimated 48 billion barrels of oil and 292 trillion cubic meters of natural gas. Hydrocarbon development is intense. Historically, Kazakhstan accounts for about 55% of Caspian oil production, while Azerbaijan contributes around 20%. Russia and Turkmenistan hold most of the remaining share. Ironically, the fossil fuels extracted here contribute to the climate warming that is drying the sea. The northern Caspian, most vulnerable. The northern Caspian, shared mainly by Kazakhstan and Russia, is the most vulnerable region. Though it covers vast areas, it holds only about 1% of the Caspian's total water volume. Small drops in water level expose enormous stretches of land. This is where shoreline retreat is most dramatic. Shoreline retreat by country. In Kazakhstan, shoreline retreat has been the most severe. Between 2001 and 2024, parts of the coastline receded by up to 56 kilometers. If water levels fall by 10 meters, some coastal settlements could end up 89 kilometers from the sea. In Russia, especially near the Volga and Ural deltas, some areas are experiencing shoreline retreat of up to 8 kilometers per year. Under a 10-meter decline scenario, Russian settlements could see the shoreline move 44 kilometers away. In Turkmenistan, recession is severe around Karabogaz-Joel Bay. The port of Turkmenbashi could face a 16-kilometer increase in distance to open water. In Azerbaijan, the port of Baku now requires constant dredging to remain operational. In Iran, the southern Caspian is deeper, over 1,000 meters, so shoreline movement is less dramatic, though water loss is still occurring. Fishing under strain. All 5 Caspian states depend on fishing. But overfishing, pollution, and shrinking habitats have caused severe declines. Sturgeon populations collapsed so dramatically that all 5 countries agreed to a commercial sturgeon fishing ban through at least 2026. Fishing has shifted to smaller species such as sprats, mullet, herring, and Caspian cutum. Each country now controls an exclusive fishing zone extending about 46 kilometers offshore, under the 2018 Caspian Convention. Shipping, pollution, and the Middle Corridor. Shipping is another growing pressure. Globally, shipping already accounts for over 2% of human-caused carbon dioxide emissions. In the northeastern Caspian, ports at Aktau and Kurik transport about 15 million tons of oil per year. Between 2013 and 2022, at least 15 oil spills were officially recorded, but satellite studies detected as many as 329 spills, mostly from ship discharges. Cargo traffic is rising rapidly along the Trans-Caspian Middle Corridor, linking China to Europe. The World Bank projects cargo volumes could reach 11 million tons by 2030, increasing emissions and evaporation further. Future projections. Climate models paint a troubling future. By 2100, scientists project a further 8 to 30 meters of water level decline due to warming alone. When human water diversion is added, losses could increase by another 7 meters. That would reduce the Caspian Sea's surface area by up to 25%. The Aral Sea Warning. This is not an abstract risk. The Aral Sea, once the world's fourth largest lake, lost over 90% of its water due to river diversion for agriculture. Its collapse destroyed fisheries, poisoned land with salt, and reshaped the regional climate. The Caspian Sea is not the Aral Sea, but the warning is clear. A choice still exists. The Caspian Sea remains a vital natural resource. For energy, for food, for trade, and for life. But satellites show the truth with quiet precision. The sea is shrinking. The shoreline is retreating. The balance is breaking. What happens next depends on choices made today, by governments, industries, and societies that depend on this inland sea. Because once a giant inland water body begins to vanish, history tells us one thing: it rarely comes back.